the amount of carbon in it, the carbon-14, is only about half the amount found in living human being. So in that Egyptian mummy, let's say 50%. So let's say 80, the present value. The present value of carbon-14 is 50%. So I'm going to write 50% here. And this is, and S0, the amount at the beginning was 100. And then they give me the equation. Okay, I'm using Y. They use Y, doesn't matter. I can use 80. So Y is 50, Y0 is 100. The important thing is that whether it is Y or T or H, just know that this is the present value. This is the future value. I mean, this is the present value. This is the original value. And this is an exponential decay. We said this the first day of class. It's an exponential decay because the exponent is negative and E is 3.1. If you found E, it's greater than 1. In other words, E is the same as B here. E is bigger than 1, but the exponent is negative. So since the exponent is negative, it's a decay. That's what I'm trying to stress. So the exponent is 0.00012, all right, 16 t. So the same method you use to solve the first one. So you isolate the exponential function e to that power. So let's isolate that. So let's isolate. Remember, this is the same thing as what we did before. I'm going to do 3 of them just so you know that you can do it. It's not difficult. So I'm divide both sides by the original. I'm going to divide by 100. So that cancels. And then I now have 50 over 100, which is the same as 0.5. So I write 0.5 here. 0.5 is equal to the isolated e and the exponent 0.0001216 t. Okay, now because the bases are not the same, like we started, if the bases are the same, the exponents are the same, are equal, but the bases are not the same. So the exponents are not the same. They are not equal. So we have to take natural logarithm. By the way, why am I taking natural logarithm? I am taking natural logarithm because the exponential function is e. Exponential function is e, so I'll take natural logarithm. So let's do that. So we're going to take natural logarithm. I'm going to clean some of these first. All right. So I'm going to clean. So we are going to take natural logarithm of both sides because the exponential function is base e. So I'm going to now say natural log of 0.5 on the left is equal to natural log of e to power negative 0.0001216 t. We wanted to know that we are solving for t. T is in the exponent. So we have to do whatever we can to bring it, to isolate it. And to isolate it, we already know that one of the laws of logarithm says that the exponent is coefficient. So I can rewrite it so that the exponent will be coefficient. So natural log of 0.5 is equal to, I'll bring down all the exponents, negative 0.00001216 t multiplied by natural log of e. Again, natural log of e is 1 because natural log of e is log e to base e. Log of any number to its base is 1. All right, now I'm going to divide both sides by the coefficient of t because I'm solving for t. So I'm going to divide both sides with the coefficient of t, negative 0.0001216. Divide both sides by, so negative 0.0001216. If I cancel this, now I will get my calculator and plug this in. All right, so now I'm going to claim more. I need to claim more. All right, so now I have isolated t. The isolated t is equal to the quantity in the left-hand side. Remember, I'm told to calculate the number of years the Egyptian mummy died. It has to be number of years. So this cannot be my answer. That cannot be my answer. So then I will get my tidy up. Let me tidy up. So t that I'm looking for is equal to the quantity in the left-hand side. So I have natural log of 0.5 divided by negative 0.0001216. So I get my calculator and throw all those things into my calculator. Take your time. Instead of making a mistake, you want to do them step by step. So I like to just put a natural log of 0.5, get an answer, then divide by coefficient of t. And that's what I'm going to do right now. So I'm just going to do that. And I'll get my calculator. And I will now go to natural log. Notice that natural log is on the left-hand side, ln 0.5, close parenthesis, and I get an answer. You don't have to do it my own way. Then divided by the coefficient of t divided by, don't forget that this is the negative you use, negative 0.0001216. And then when I hit enter, my answer is, because I'm told to leave my answer to the nearest year, so my answer is going to be 5,700 years. So t is 5,700 years. Don't forget to write years, or 5,700. Therefore, the Egyptian mummy, that human being doesn't have to be a woman, but a dead bone, a human dead bone is called an Egyptian mummy. Okay, so it doesn't have to be a human, an Egyptian. It doesn't have to be a mummy. It's just a name for, a dead bone, a human being, a bone of a human being. Anyway, so we just calculated that from the calculations of the engineers, that person died 5,700 years ago. 5,700 years ago. Okay, so this is another, let's go back and get another practice, another application. May not actually be application, but the important thing is that we are combining everything we already learned. Okay, you can also be told to solve this equation. You could be told to solve this equation right here. We'll continue with the application. This equation right here, when you are given this, notice that the bases are equal. The bases are equal, it is no problem. So it is e to power 8x minus 1 is equal to e to power 6. I can open that parenthesis because 6 is going to multiply x, so I have 6x. And then the bases are equal. Therefore, the exponents are equal. It's no problem. We have already known that if the bases are equal, the exponents are equal. But if the bases are not equal, that is when you take natural log of both sides. The base is e now. the bases are equal. So I'm not going to take natural log of both sides. You see? So then the exponents are equal. So 8x minus 1 is equal to 6x. Then I collect like terms together, minus 6x on both sides plus 1. I just want to do them at the same time. So, and then minus 6x here. And then I have 2x is equal to 1. Divide both sides by 2. X is equal to 1/2. Therefore, x is 1/2. All right, so this is an easy one just because the bases are equal. All right, so, and then look at this kind of question. If you're told to solve it, you should be able to solve the problem. Solve the following problem. You can take natural log if you ordinary logarithm if you want to. Okay, if you want to take ordinary logarithm, another way you can do this one right here. You can put it as 9 to the power x minus 5 is equal to 9 to the power 0. If you don't want to take natural log, if you have, because 9 to the power 0 is equal to 1. So you haven't changed anything in that equation. So you now say x. You can always manipulate your exponential function in a way if you know what you're doing. So x is equal to 5. But you can actually take natural log of this. But guess what? Natural log of 1, I mean, logarithm of 1 will be also will be 0. Logarithm of 1 is 0. Okay, well, let's get another application because we did it. I know that I didn't have up to half of the class that day. I didn't have of the, okay, the half-life of a radioactive substance is 27.5. So half-life is 27.5. Find the exponential decay model for the substance. Suppose that how long will it take for the sample of 500 to decay to 400 grams? Let me come back to this. Let me come back to this one. Let's just get the easy ones. This is actually the one that, okay, just make the ones that, make sure we got time to do the ones that are easy. You can pass the test. And then that half-life is still going to be in the final exam though. Okay, so we have to do it. So final exam. Suppose that 2,500 is invested. Remember, invested in account. This is investment. Another application. Some of you did not come to class, so I'm going to say this again because some of you did not come to class that day. Remember that if you are doing investment and it's going to be paid quarterly. Quarterly means every 3 months, 4 times a year. Semi-annually, 2 times a year. Monthly, 12 times a year. Daily, 365 times a year, and so on. Okay, so remember the formula. 80 is equal to, I can just write this one, equal to P0 into 1 plus 1 over R over N. Remember you have to remember it for this test though. Remember, you have to remember this. This is the compound interest formula we talked about when some people were not here. I know that because I didn't even have half of the class. Compound interest formula, don't forget that. So that's what you're going to use to solve the problem here. Okay, wow, this one says compounded continuously. If it is compounded quarterly, semi-annually, use this one. If it's compounded continuously, you use continuous compounding. So in this question, actually, this is continuous compounding. So this is P0ERT. Okay, this one is continuous compounding. So for this question, let's solve this because it doesn't hurt if we do it again. So I just want to select these questions are actually in the test. I'm just telling you that. Okay, so, and they will show up again in the exam. Exam is next month. So even if you don't want to do the test, that's okay. If you skip the test, final exam will make it up for you. For those of you who always skip the test with excuses, this is Unit 3. If you skip the test, final exam will make it up for you. If you skip Unit 4 test, final exam will make it up for you. Please don't email me to tell me you want to make up the test. Don't email me because I will not open the test for you. If you skip the test, that's fine. Final exam will make up one test. The other one will be a 0. If you already missed one, if you missed one test and you missed another one, final exam will make up one of them. The other one will be a 0. Just make up your mind what you want to do, okay? All right, now we want to solve this problem, and taking all we are given, P0, the original amount is 2,500. Sorry. The interest rate is in percent 3.25, but you have to change interest rate to decimal. So I'll change it to 0.0325. All right, find the amount of time that it will take for the account to grow up to 3,400. So 3,400. They want me to find the amount of time the money will grow up to 3,400. So as soon as I'm given all this, I want to make sure. So I am given the future value. This is the future value of the money. The present value of the money is 2,500. They want me to calculate the time. They also give me the rate. I have everything. I have everything, so I can now solve. So I'll go ahead and plug into the formula. So let me plug into the formula. The future value is 3,400. The present value is 2,500. The base is E. You want to know that the base is E. The rate, the investment rate is 3.25%. I need to put 5 here. Okay, 0.0325. This is not a decay. It is not an exponential decay because the exponent of E is positive. And T, I'm told to solve for the time. Another question that is asking me for a number of years. Okay, so which means I am going to isolate E again. It doesn't matter if it is about Egyptian mummy or carbon-14. Other questions in investment can ask you about exponential function. That with E, that can ask you to isolate, find the value of T. Okay, let's do that. Divide both sides by initial amount. Divide both sides by the initial amount. This cancels, and 2 zeros canceled here. So I have 34 over 25 is equal to E to power 0.0325T. Then, according to logarithm or law of exponents, the exponent is coefficient. So what I'm going to do now is take logarithm of both sides. Why? Because I want to use the law of logarithm to solve this problem. There is no way that the left-hand side, the base here, can be equal to the base here. No. There's no way that 34 over 25 can be equal to E. So I have to take another method. Whenever you are solving exponential and logarithmic function, you should be there. Watch out what you can do, what you cannot do. How can you take advantage of the inverse properties of exponential and logarithmic function? Wherever you can take advantage of it, do that. So natural log of 34 over 25 is equal to natural log of the quantity here, 0.325t. Now that I have the equation this way, I can now say that exponent is coefficient on the right hand side. Exponent is coefficient 0.0325t multiplied by natural log of e. 1, bring down this. Somebody please mute yourself, okay? Okay, so I have natural log of 34 over 25 divided by 0.0325, 0.0325. Then I'll put that into my calculator. So I can now simplify. And whatever answer I have is the number of years. My answer better not be negative, because the number of years cannot be negative. So if your answer is negative, go back and find out where you made a mistake. Everybody makes a mistake. Try to catch your mistake. So I'm going to use my calculator, put the quantity in the left-hand side. Be careful to use parentheses wherever in. So go to natural log, 34 divided by 25, 34 divided by 25, close that parenthesis, and I am going to finish with that, then divided by the denominator there is 0.02, 0.0325, and then I get an answer. So my answer is 9 point. Let me see how many decimal places. How many decimal places do they want me to keep my answer? I think I pulled it up. Let's go up and check on it. Okay, type an integer or decimal rounded to 1 decimal point. Okay, so my answer will be the amount will grow from 2,500 to 3,400 in 9.5 years, or 9.4 approximately, 9.5 years. Okay, so the amount will grow up to that in 9.4 years. Okay, well, let's get to yeah, I know you can do. We have done all the laws of logarithm. I know that we did the exponential function. I mean, another, yeah, exponential. Remember that you can be told to find the exponential regression. Okay, everybody, look at this question. Look at this question here. We have 4e to the power 5x plus 5 is equal to 10. But this is an exponential equation. I'm told to solve the exponential equation. So 4e to the power 5x is equal to 10 minus 5. Divide both sides. I'm just going to clean this one up, and I have 5 here. Divide both sides by 4. And I have, let me come over here. So now I have e to the power 5x is equal to 5 over 4. Now in this situation, this is an exponential equation. And the bases cannot be equal. There's no way they can be equal. Somebody tell me what to do. Tell me what to do, somebody. If you have been listening to me, what do I do at this point? I want to finish this equation, to solve the equation. And I have come to a place where the bases are not equal. What do I do now? Somebody. Okay. By the way, I need to call somebody. I don't have to wait for you to say something. So I'm just going to call somebody who is in class to answer. Okay. Okay, well, that's good. We have 21 out of 24. Caleb Stain Smith, can you please answer this question? I have come to the base is E on one side. On that side is not E. And I'm expected to solve the equation and get decimal or a number. What do I do? Is Caleb Shan here? Is Caleb here? All right. Kadin? Okay, Caleb, go ahead. Go ahead.
I'm not sure what to do.
Okay. I'm going to ask another person. Cameron Lay, what do I do? Based on the left-hand side is E. Based on the right-hand side is not E. I need to solve the exponential equation. What do I do?
Could you go back to the question just so I can see it?
Okay. All right. So let me go back to that question. The question. Go back to that question. All right. So this is where we are. So this is the question here. And we come over here. This is the after clearing the exponent and the coefficient. I mean the coefficients. So at this point now, what am I going to do? What am I supposed to do at this point to finish solving this problem? You take natural log of both sides. Take natural. This is what I have said since the beginning of the class. Take natural log of both sides because the base is E. If the base is not E, take common logarithm of both sides. Okay, so I'm going to take natural log of both sides. So natural log of E to the power 5x is equal to natural log of 5 over 4. The essence of doing that is so that we can solve the equation. Okay, the exponent is coefficient in logarithm. So 5x multiplied by natural log of E is equal to natural log of 5 over 4 on the right-hand side. But natural log of E is 1. So now I'm solving for x. So 5x is equal to whatever is on the right-hand side. So x is equal to natural log of 5 over 4 divided by 5. So I'll put that in my calculator. Okay, I'm going to ask somebody else. Where do I go in my calculator to assess natural log? I'm just here right now. I want to finish solving this problem. So where do I go to assess natural logarithm? Somebody. All right, I'm going to call somebody. I just don't want to be talking to myself alone. That's why I'm trying to call you. All right, Cameron, please answer. I know you are too, though. One of the Cameron answer. That is natural log right here. Go to natural log. This is natural log. All right. Then 5 divided by 4. 5 divided by 4. And then I'll do it one by one. Hit enter. Then divide whatever your answer is by 5. And so my answer, the value of x is 0.04 4. It depends on the number of decimal places, by the way. Okay, so the solution set is you put it in A, you put the answer there. You find the number of decimal places they want you to answer the question. All right, so let's go back to remember we did the laws of logarithm, so you should be able to expand this logarithm, use the properties of logarithm. Okay, so we can say log to base 4 of 9, because multiplication is addition in logarithm. I can also say plus log of y to base 4. Division is subtraction in logarithm, so minus log of z to base 4. So this is one of the easy questions here. That's one of the easy questions here. All right, let's go to another compound interest question where we shall compound not continuously this time. Compounded not continuously this time. Let's see, there's another question on compound interest. I think we did number 7 there already, but let's do it again. And some people, okay, let's do number 7. Quickly, number 7, it says find the amount that results from given investment. Okay, investment is very, very important. When you get to calculus now, that is going to be investment. A lot of calculus 1, you have investment. Calculus 2, you have investments. So you use logarithm and exponential function to do investments. Then you differentiate, you integrate. It depends on which class you are. But anyway, in this question here, $200 is invested at 12% compounded quarterly. Can someone remind us? If you know the answer, please say it. Compounded quarterly, how many compoundings in a year? So the first thing is write the formula for compound interest, initial amount into 1 plus the rate over the number of compoundings multiplied by the number of compoundings times time. The future value is equal to the present value into 1 plus the rate in decimal divided by the number of compoundings, all to the power number of compoundings times time. Okay, so you find out all these things. Okay, so I know that the present value is $200. The rate is 12%, 0.12. Rate must always be in decimal. I'm given the time. Time is 4 years. So what am I solving for? That is the question you will ask yourself. What am I told to solve for? Because you cannot start solving without knowing what you're told to solve for. So I am told to find the future value, 80, the amount after 4 years. They told me to find the amount after 4 years, so I know my answer will be in dollars. I know but my answer will be in dollars. Okay, so that is what I'm looking for. Future value is equal to present value is $200 into 1 plus the rate is 0.12, 12%, all over. Compounded quarterly means that n is 4, quarterly, 4 times a year. All to power 4 times time. Time is also 4. All right, so now I can simplify and solve the problem. You can start from the the parentheses. Okay, and if you want to start with parentheses, you can say, okay, can four can be the lowest common denominator, and so you can rewrite that as 200 into 4.12 over 4 out to exponent 16. And so it's easier. This is easier to simplify. Then you put it in your calculator. You get this in your calculator and simplify. All right, so when you are told to solve a logarithmic equation, look at number 8, everybody. Number 8, if you're given a logarithmic equation to solve log, and the base is not 10, remember, you change the base. You have to do change of base because you cannot solve it. If you're not supposed to solve it, that's fine. Then you can expand it if you're told to expand. So let me expand it, but I want to make sure that I emphasize this. Suppose I'm told to find an answer to this. That's not what I'm told to do now. In this question, I'm told to express as a sum. So let me just express as a sum. Because it's division, it is log to base 5 of 36 minus log to base 5 of 31. That's it. Simple. But suppose I'm told to find the answer, solve this problem, then I will do change of base. If I'm told to find the answer, I will change the base. So I will do log to base 10 of 36 divided by log to base 10 again of 31. So you change the base. If you're told to solve, because I'm saying, suppose you see a question that tell you in a test. Suppose you have a test and the question has log to base 5 and wants you to get an answer. The only way you can solve it is by changing the base. Change the base. Okay, and you change the base, then you put log 36 in your calculator divided by log 31. So when you have a different base and you are told to evaluate, change the base. Okay. All right. I think we have done so much, but we can also solve this problem. If you're told to solve a logarithmic problem like that, then you can change it to exponential function. If it looks weird to you to solve with logarithm, okay, change it to exponential form. So the argument of this is x to the power 3 plus 255. Then it's equal to 4 to the power 4. And 4 to the power 4 is 256. So this is 256. And so now I have x to the power 3 plus 255 minus 256 is equal to 0. So x cubed minus 1 is equal to 0. You could be told to solve this, but you already know that this is going to be x minus 1. But if you expand it, difference of 2 cubes, x squared plus x plus 1, difference of 2 cubes. And this is this part here. This part here is that part is, if you graph this equation, notice that this part is not real, it's imaginary. So the only real solution is x minus 1. I think we already graphed it before we left on spring break. Okay, I think maybe I have to leave you. That's one question that I am not going to put in this test, but it's going to be in the exam. And let me just show you the question, because I want us to have more time to deal with this question. So this question is postponed, is going to be an exam. Let me show you the question. This question is an exam. Usually it's usually an exam. So I'm going to leave this question for exam. You mark it for now, but it's a final exam. I can tell you that final exam is ready. Final exam is ready. So so you know that because you're supposed to know it, but I think you got enough to know in this unit 3. Okay. Do you have any questions? If you're here, raise your hand, please. If you are here, raise your hand so I can get a count of